Hello, good morning. Here we are to discuss about the sulfonamides and cell phones. Myself, Professor Arun Kumar Mishra, and I will let you know about the basics of sulfonamides. And before start of the sulfonamide, I will discuss about the history of sulfonamide. Generally, sulfonamides are called as sulfa drugs, as these sulfonamides are synthetic antimicrobial agent and having sulfone amide group. Sulfonamide was firstly synthesized by German chemist in 1908, and in 1917 at Rockefeller Institute the sulfonamide was added to the quinine derivative to increase the bactericidal properties. After 10 years of this invention, in 1927 at Bayer subsidiary of the IG Farben Industries, the screening of various dyes for antibacterial effect in animals was performed. Afterward, in 1931, sulfamyl group was incorporated into the dye molecule to enhance the dye's antibacterial activity and found to be effective against the streptococci. This dye was called as prontosil after amalgamation with the sulfonamide. In 1932, the prontosil, which was sulfonamide containing dye, was found to be effective to treat the hemolytic streptococci, and after 1 year of this, in 1933, the first clinical report of this prontosil use in patient was released. Actually, what happened? A 10-year of the boy was dying from staphylococcal septicemia, and he was given this prontosil. It was observed that he promptly and remarkably recovered from this staphylococcal septicemia. Therefore, this proved the effectiveness of prontosil. And in 1935, prontosil, which we are discussing about as non-toxic dye, was given orally in small doses, was quite capable to prevent the fetal hemolytic streptococci infections. This proved that it was quite capable to act as true chemotherapeutic agent only in living animals. After 2 years of this, in 1937, it was found that prontosil acts only after liberating the sulfanilamide. Actually, when the metabolism of prontosil was observed, it was releasing the sulfonamide, and this sulfonamide was quite active and potent enough to quench the available microbes. It means the antibacterial activity of the sulfanilamide was not discovered until nearly 30 years after it has been synthesized. Why? Because in 1908 it was firstly synthesized, and even in 1937 this was only identified that prontosil after its metabolism is releasing the sulfonamide, and this released sulfonamide is quite capable to inhibit the bacterial growth. In 1935 and 1936, the effectiveness of prontosil and the sulfanilamide in sepsis cases, sore throats, and the complications of scarlet fever were first reported in the various literature. Sulfonamide became popular with the introduction of new less toxic compounds, and due to very low level of the toxicity, as in case of sulfasoxazole and sulfamethoxazole, the popularity of sulfonamide class of the antimicrobes increased than other sulfonamides. Amongst the many sulfonamides that were introduced during the war years before penicillin became generally available in 1944 were more potent drugs which had enhanced the solubility in water. In case of sulfonamide, when it gets metabolized, the N-acetyl sulfonamide is produced, and this N-acetyl sulfonamide is not easily ionized and not easily metabolized and not easily excreted. Sulfonamide are mostly excreted in urine in acetylated form, which is water insoluble, and due to this water insoluble property, it's get non-ionized in urine pH condition. Therefore, there are every likely chances of the precipitation and crystalluria. The observed pK of sulfonamide is 10.4, which is this causes 50% of the drug ionization, as urine pH is around 6, and therefore on this pH this is insoluble crystals may precipitate in urine, and this precipitation of the crystals in urine is called as crystaluria. Overcome of this problem can easily be achieved by enhancing the urine flow, and this urine flow can be enhanced easily by increasing the intake of water, because sulfur drugs get concentrated into the urine before being excreted. Therefore, treatment of the UTI is one of their most common use, very clear and very beneficial, as these sulfur drugs gets accumulated into the urine. So in order to treat the urinary tract infections, these sulfonamide drugs may easily be observed as very beneficial. One more option is that if we increase the pH up to the 10, this will cause in ionization of the sulfonamide, and this will cause the formation of water soluble salts of the sulfonamide, and this can also be parallelly achieved by taking sodium bicarbonate before taking the sulfur drugs. Now coming to the classification of these sulfur drugs, sulfonamides, there are two bases of the classification. One is on the basis of duration of action, and another is based on the site of action. The sulfonamides can be classified on the basis of duration of action into the three categories: long acting, short acting, and intermediate acting. In case of long acting sulfonamides, the examples are sulfamethagyne, sulfamerazine, sulfamethoxypridazine, and sulfamethoxypridazine. And in case of short acting, the example are sulfathiazole and sulfasomidine. And in case of intermediate acting sulfonamides, sulfamizole and sulfamethoxazole. When the classification is done on the basis of site of action, the gut-acting sulfonamides include the succinyl sulfathiazole, and systemic sulfonamides include N-substituted sulfonamide except the sulfaguanidine and sulfonamide which are used topically. Renal sulfonamides are the sulfasoxazole, that is also called as sulfafurazole, and topical sulfonamide are sulfamylon and silver sulfadiazine. The another category ophthalmic sulfonamides are sodium sulfacetamide. These are the two bases of classification of the sulfonamides. These are the chemical structures of the sulfonamides, can easily be drawn. Now coming to the some basic points of the chemistry associated with the sulfonamide. The basic sulfonamide structure includes two moiety. One is sulfonamide, that is SO2NH2, and another is amino moiety NH2. These two are at the para position of the benzene ring. Large number of the sulfonamide derivatives were obtained by substitution of the hydrogen atom on the nitrogen of sulfonamide group at N1 position, whereas small number of the active sulfonamides drugs were obtained by substitution of the hydrogen atom on the nitrogen of aromatic amino group. This hydrogen can be easily replaced, and this hydrogen can easily be replaced. If this hydrogen is replaced, number of series of the sulfonamide can be obtained, and the same is applicable for this fourth position. The introduction of various substituents resulted into the products with different physicochemical pharmacokinetic properties, which includes degree of protein binding, metabolism excretion, and pharmacodynamic properties as well. One very important point is that this sulfur and this nitrogen creates the SN bond, and this SN bond cannot be easily broken. Why? Because due to the rigidity into the structure of this functional group. One very common and very popular attribute of the sulfur drugs are that sulfur drugs are amphoteric in nature, and these sulfonamide loses a proton to form salt which is more soluble than free sulfonamides. This between this structure, after removal of one hydrogen from this nitrogen, easily creates a negative charge on this nitrogen, and this removed hydrogen gets attached with this NH2 and is causing NH3. This easily provides the picture of amphoteric nature of the sulfur drugs. Now coming to the very important point of this sulfur drugs, the mechanism of action. Actually, the pteridine combines with the para-aminobenzoic acid, which is commonly called as PABA, and glutamic acid. Means after interaction of the pteridine, PABA and glutamic acid, in the presence of dihydroptorate synthetase, they forms dihydroptoric acid. This dihydroptoric acid, in the presence of glutamate, forms the dihydrofolic acid. This dihydrofolic acid, in the presence of dihydrofolate reductase, synthesizes tetrahydrofolic acid, and this tetrahydrofolic acid gets interacted with other chemicals and get involved directly in the synthesis of base pairs, which are directly associated with the synthesis of DNA. In case of sulfonamide, what sulfonamide performs? Sulfonamide actually inhibits the dihydrotorate synthetase. Therefore, due to interaction of sulfonamide with the dihydrotorate synthetase, pteridine, PABA and glutamic acid cannot easily convert and produce into the dihydrotoric acid. This means the synthesis of dihydrotoric acid is prevented. And similarly, the trimethoprim, what it performs the interaction with the dihydrofolate reductase and inhibits the conversion of dihydrofolic acid into tetrahydrofolic acid. All these ultimately prevents the synthesis and the formation of base pairs of the DNA, base pairs for the DNA, and ultimately the bacteria cannot survive. Furthermore, these were the some basics, and in our next lecture we will discuss about the synthesis and SAR of the sulfonamides. Thanks.